Alright, now here we're going to apply some of that conservation of energy, the formulas we were building in the notes. It says referring to the previous question, so let's pull out the information from the previous question. We were given the distance, the voltage in here. So we have the distance between the plates as 0.18 meters, I think. Yep. And 6.03 volts. And a voltage of 6.03 volts. I'm not going to use that electric field number just in case it was wrong. And maybe if I have to calculate it or use it, I will. But I'll try to avoid it as possible. They're referring to an alpha particle in this question. So the very first thing I do is write down the mass of an alpha particle. 6.65 times 10 to the negative 27 kilograms off my data sheet. And the charge on an alpha particle is twice the elementary. So 2 times 1.60 times 10 to the negative 19 coulombs. The alpha particle is placed on a positive plate, which is telling us the initial velocity is 0 meters per second. What we want to do is figure out what its final velocity will be after it hits the negative plate. So this is a conservation of energy. And you'll notice on your formula sheet you have change in voltage, change in energy, divided by Q. And we know that this gravity is not a factor in here because the masses of these elementary particles is too small to worry about gravity. Never, ever, ever consider gravity for alpha particles, electrons, protons, and neutrons. Have a look at those masses. 10 to the negative 27. Multiplying that mass by 9.81 is still a very, very small number. So the electric forces for these are many times stronger than the gravitational forces. Do not consider them. Don't need to worry about friction for those tiny little particles because they're so small, they won't experience any friction either in these cases. We also know that the energy change from potential, so therefore equation 1, change in energy equals Q change in voltage. But we also know that kinetic energy is equal to 1/2 m Vf squared minus Vi squared. Your energy change from two different points. So what we can do is we can equate these two formulas, which is what I did in your notes, and Q change in V can equal to 1/2 m Vf squared minus Vi squared. So the change in velocity is going to be due to the change in potential energy of putting these things between two parallel plates. Just like when you hold something above the earth, has a whole bunch of potential energy, you release it, it changes to kinetic. We're just now using the potential energy for electricity, which is QV, not MGH. So what we want to do is manipulate this for VF. Now the nice thing is VI is 0, so we can really simplify this question as being Q change in V equal to 1/2 m Vf squared. Multiply by 2, so you'll get 2 QV divided by mass, take the square root to find your final velocity. 2 times the charge times the voltage divided by the mass, take the square root to find velocity. Well, we have Q, we have V, we have M. Do the substitution. 2 times, and the charge is twice 1.60, so I'm just going to write it as 3.20 times 10 to the negative 19 coulombs. the change in volts from one plate to another, 6.03 volts, divided by the mass of an alpha particle, 6.65 times 10 to the negative 27 kilograms. Take the square root of this number, and your final velocity will be equal to 2.41 times 10 to the 1, 2, 3, 4 meters per second. Little piece of advice for you, a tip to ensure that you're doing these right. Alpha particles tend to be the slowest of those elementary particles. They're the biggest, so they will move the slowest. They tend to be in the neighborhood of 10 to the 3 to about 10 to the 5 meters per second. Electrons tend to be the fastest because they're by far the smallest particle, so they'll get lots of change in energy. They tend to be in the neighborhood of 10 to the 6 up to 10 to the 8, but nothing can travel faster than the speed of light. So as soon as a particle has mass, it will have to go less than 3 times 10 to the 8, but electrons can get up to really close to the speed of light. But nothing should be bigger than 10 to the 8. Alpha particles should be in the 10 to the 3 to the 10 to the 5. Electrons 10 to the 5 or 10 to the 6 to 10 to the 8 in most cases.